So this is a video for chapter 6, D-Day number 1 for integrated 1. Number 1, Cassandra wears 2 types of hairbands, large and small. She has a total of 50 hairbands. The large ones cost $3 each, and the small ones cost $1 each. So far, she has spent a total of $106. How many of each type does she own? This is going to be our question here. How many of each type does she own? That's going to be our variables, okay? So how many of each type does she own? So I am going to let S equal number of small headbands or hairbands. And I'm going to put a capital L so it doesn't look like a 1, is number of small hairbands. Sorry, large hairbands. And I'm going to be writing 2 equations. One equation is going to come from, she has a total of 50 hairbands. So I am going to write for the first one, and I'm going to do a cursive lowercase s, so it doesn't look like a 5. S plus L equals 50. Second equation, let's see, the large ones cost $3, the small ones cost $1, and she spent a total of $106. Okay, so let me keep the same order I have originally. So I'm going to write the small ones first. So $1 times each S, or just S, plus $3 times each large, so 3L, is equal to 106. I am going to multiply the top equation by a -1 so that it will become a negative S minus L equals a -50. I'm going to rewrite the second equation, which is S plus 3L. Let me do a better 3 there. So S plus 3L is equal to 106. I am going to add, and my S's will eliminate. So I'm going to get 2L is equal to 56. I'm going to divide by 2, and I'm going to end up with 28 large ones. Now, there were 50 total headbands, okay? So basically, if I was to take 50 minus 28, I end up getting 22. That's going to equal my small hairbands. So Cassandra bought 28 large and 22 small hairbands. And that's going to be my answer. Okay, number 2. 2 is asking us to do 2 things. They want us to solve the system by graphing it on the graph and finding the point of intersection, and then solving it algebraically. So to graph this, let's say I do this first one in this pink. So my y-intercept is this 1. So I'm going to come up to 1. My slope is -4, which means I'm going to go from here down 1, 2, 3, 4 to the right 1. And I'm going to keep doing that. 1, 2, 3, 4, right 1. And let me just go the other direction. So I'm going to go up 1, 2, 3, 4, left 1, up 1, 2, 3, 4, left 1. And then I am going to get a line. Maybe make it a little thicker. And I'm going to have the line go through these points. Now I want to be accurate with my line because I'm trying to solve where they cross. Okay. And then I'm going to graph the other one. So for the second one, let's say I do it in this teal color. And let me make it not see-through. Okay. So I'm going to be starting at -2. My slope is a -1. So I'm going to go down 1, right 1. And you see right there, they crossed. Down 1, right 1, down 1, right 1, and so forth. So I'm going to connect these. I already see where they're crossing. So I am going to connect it with a line. And let me just move that line I was off. There's my line. And my answer to this system is the point that these cross at. And so these cross right here. And the coordinates of that point is 1, -3. 1, -3. That's their point of intersection. Then I'm going to solve this algebraically, and I hopefully will get the same answer. So since both of these are in y equal form, I'm going to use equal values. So I am going to take -4x plus 1, and I'm going to set it equal to -x minus 2. I am going to try to do my x's first. So I'm going to add 4x. I think that would be the best choice for me. I'm going to get 1 on this side, 3x minus 2 on this side. I'm going to add 2 to both sides. I get 3 is equal to 3x. I divide both sides by 3, and I get x equal 1, which is what I got up here also. Now I'm going to take this 1 and plug it into either equation. I think I'm going to do it into the second one. So I'm going to go y equal. Now, negative x means negative whatever your number was, which happens to be a 1, minus 2. So I get a -1 minus 2, which is a -3. So I still write my answer as a point, and you see I did get a 1, -3. I got the same thing. You need to get the same thing when you graph it, where they cross, and when you solve it. Okay, number 3. Okay, solving like we did above, but we're just doing the algebraic. So in this case, we have one of them y equal, one of them not. I'm going to use substitution. So I am going to come here and take what y is equal to and put it into y in the second equation. So I am going to have 4x plus 3 times my y is equal to 55. And my y is the same as a 2x plus 5. So I am substituting this 2x plus 5 in place of this y. So right here in place of this y, I put my 2x plus 5. Now I'm going to work that out. So I'm going to have a 4x plus, and here my 3 is going to distribute to both of these, and I get a 6x plus 15 is equal to 55. I am going to clean up what is on this side of the equal. When I do, I am going to get a 10x plus 15 is equal to 55. I'm going to minus 15 from both sides. I get 10x is equal to 40. When I divide by 10, I get a 4. So I get 4 comma something. And I am going to go put this into the y equal equation up here. So I'm going to go y equals 2 times my x, which is 4 plus 5. So I get 8 plus 5, which is 13. So this is going to be 4 comma 13. On letter B, these are both in standard form. I notice I have a 3x and a negative 3x, so I can use elimination and I could just add these two equations together. And when I do, my x's are going to cancel out. And then my y's, I'm going to get a 3y is equal to 9. Divide by 3 and I get 3. So I'm going to put it into either equation. I think I'm going to do it into the one that doesn't have negatives. So I think I'm going to do it into that one. So I'm going to go 3x plus 5 times my y, which is 3, equal 15. I get 3x plus 15 equals 15. I minus 15 from both sides. And when I do, I get a 0. Now, this is where some of us are having trouble. When you divide 0 by 3, you get 0. It's not undefined. Only if I had 0 on the bottom would it be undefined. So my solution is 0 comma 3. On C, both of these are in standard form. I need to multiply one or both equations so that I can get rid of either my x's or y's. I'm actually I can multiply the top one by a -2. But again, I'm just going to show another method. I noticed that each of these is divisible by 2. So I'm actually going to divide it by a -2, a -2, a -2. When I do that, this top equation is going to stay 2x plus 3y equals -1. The bottom equation, when I divide, is going to be a -2x, which is what my goal was, to get the x's. Minus y is equal to a -1. I add these two equations together. I get 2y is equal to -2. So my y is going to be a -1. I then am going to put that into either equation. Let's say I put it into the 2x plus 3 times y, my y being a -1 equals -1. 2x minus 3 equals -1. I add 3. I get 2x is equal to 2. I divide by 2 and I get x is equal to 1. So 1 comma -1. On 4, word problem. So on this, in a bag, there are 4 red marbles, or no, sorry, 4 more red marbles than green marbles. There are a total of 76 marbles in the bag. How many of each color are in the bag? Define your variables, write your equations, solve the problem, write your conclusion in a sentence. Okay. So here it says how many of each color are in the bag. So I'm going to let R be the number of red marbles and G be the number of green marbles. Okay. So let R equal the number of red marbles. And I'm going to let G equal the number of green marbles. Now I'm going to write two equations. One equation is going to be 4 more red than green. So you want to pay attention to which one you have more of. You have 4 more red than green. You have more red. Now 4 more means I'm adding 4 onto something. It's very tempting to add it onto the red, but I have more red. I have 4 more red. So I don't want to add the 4 onto the red and set it equal to the green. I'm going to add the 4 onto the green and set it equal to the red. So my red is equal to 4 more than my green. Okay, that's my equation. Second equation is going to be dealing with total of 76 marbles. So for that one, I'm going to take R plus G is equal to 76. Now for this one, I noticed that one of them is R equal. So I'm going to take this and put it into this equation for R. So instead of R plus G, I'm going to have 4 plus G. Okay, that is my R. Plus, and let me just write the rest of that in purple, plus G is equal to 76. So this right here was my R. Okay. So now when I combine this, because these are on the same side of the equal, I get 4 plus 2G is equal to 76. I minus 4 from both sides. I get 2G is equal to 72. I divide by 72 and I get 36. 36 green. And remember, the red had 4 more. So if I take 4 plus 36, I end up with 40. So I need to write a sentence. There were 36 green and 40 red marbles in the bag. Okay, now the next sections are review. So this one here, if f of 1 is equal to 3 and f of n is equal to f of n minus 1 plus 2. So this right here is your recursive formula. This right here is telling us that the first term of that sequence is 3. This is saying that it's arithmetic because we're adding 2, and they want us to list the first 5 terms. So the first term is going to be 3. And then again, because of that plus 2, I'm adding 2. So I get 5 and I add 2, 7 and I add 2, 9 and I add 2, 11. Those are my first 5 terms of the sequence. On number 8, they want us to find f of 4. So what that means is basically, if I put in 4, what do I get out? So I know it's going to be 4 comma what? That's really kind of what I'm thinking about. So just visually what I'm going to do on this is I'm going to get a line to get a little bit transparent. And I'm going to draw that line in at where my x is 4. This is where my x is 4. Okay, right here. And then when my x is 4, what is my y? So I come here and I see, oh, my y is -2. That is my answer. Okay, so f of 4 is equal to -2, because really 4 comma -2 is a point on this graph. Right here, that point is 4 comma -2. But my answer is -2. On number 9, is the point 3 comma 3 on the line? Justify your reasoning. So what I'm going to do is I'm going to substitute that in for my x and y. So I'm going to go 3, which is my y, is equal to -2 times 3, which is also my x, plus 3. So I get 3 is equal to -6 plus 3. I get 3 is equal to -3, which is not true. So what that means is 3 comma 3 is not on the line because it does not make the equation true. On number 10, simplifying, we always want positive exponents when we do. First thing I'm going to do, I am just going to keep the top as is for a second, x to the 6x to the 7th, y to the 2nd. Now the bottom, what I'm going to do is I want to work that out. So what's going to happen is my 3y is being squared, which is going to be a 9y squared. Now, what I noticed right away is I have a y squared on top and a y squared on bottom. So those are going to cancel out. And then if I'm focusing on my 6 and my 9, that's just really a 6 over 9, which I can reduce. So my final answer is going to be, because I can reduce both of them top and bottom by 3. 3 goes into 6 twice. 3 goes into 9 3 times. So it's going to be 2/3. And then I have an x to the 7th on top. And that's my answer. Let me just make that look like a 2. So 2x to the 7th over 3. On 11, we want to solve for y. So I want to get this 3y, positive 3y by itself first. So my first step is I'm going to minus 2x. I'm going to minus 2x. And I'm going to get 3y is equal to either 12 minus 2x or a negative 2x plus 12, whichever way you want to write it. Then I'm going to divide by 3, divide by 3, divide by 3. And I get y is equal to negative 2/3 x, which would be my slope if I was going to graph this line, plus 4. And that's your equation. On 12, sketch a graph to represent the following situation. Rigo is given a 5-mile head start and rides his bike 2 miles per hour. Label your graph. So this is going to be hours, and this is going to be miles. And we know that he has a 5-mile head start, which means he is starting right here at 5. And then he's going 2 miles every 1 hour. 2 miles every 1 hour. And I am going to connect it with a line. And that's our graph. Next situation, we're going to multiply this out. So for this, I am going to do the box method, area model. I have a 2x and a negative 5, a 3x plus 4. And when I multiply to get this box, I get a 6x squared. When I multiply to get this box, I get a negative 15x. When I multiply to get this box, I get an 8x. And when I multiply for this box, I get a negative 20. So when I combine like terms, my like terms being this and this, I am going to get as my final answer 6x squared minus 7x minus 20. That is my answer. You need to write it out. On 14, we're going to solve this equation. We want to be careful. This 5x is not doing anything right now. What's going to happen is this negative 2 is going to distribute to the x and to the 3. So I'm going to get a negative 2x, and a negative 2 times a 3 is a negative 6. Now on this side, I can combine like terms. Those are going to combine and give me a 3x minus 6 is equal to 10. Now I'm going to add 6 to both sides. I get 3x is equal to 16. I divide by 3 and I get 16 over 3, which is not a nice number. Just leave it. And that's the end of this video.